about the project title Efficient Privacy Preserving Machine Learning for Blockchain Network. Introduction. The project's primary objective is to improve the levels of privacy and security within machine learning applications. This is achieved through the integration of two key technologies, blockchain and differential privacy algorithms. By combining these two approaches, the project seeks to create a more robust and secure environment for machine learning. In the past, machine learning models were typically trained and operated on centralized servers. This approach had inherent vulnerabilities, particularly concerning data privacy. If the central server were compromised, it could result in the exposure of sensitive data and compromise the accuracy of the machine learning models. The project leverages blockchain technology to address these concerns. Blockchain is essentially a distributed ledger system consisting of multiple nodes or servers. It is used to securely store machine learning models. By distributing the models across a network of nodes, the project ensures the data privacy and integrity are maintained. Even if one node is compromised, the overall network remains secure, making it an ideal solution for enhancing privacy and security in machine learning applications. Objective. The project's main goal is to improve privacy and security in machine learning. It achieves this by incorporating blockchain technology to create decentralized and privacy-centric processes for both model training and prediction. Blockchain is utilized as a secure platform for storing and managing machine learning models. It ensures the immutability of records, making it extremely difficult to tamper with the data. Additionally, it establishes a decentralized infrastructure for sharing and making predictions using these models. Secure Hash Algorithm (SHA) is employed to create unique hash codes for transactions and data stored on the blockchain. This enhances security by confirming the integrity and authenticity of information, providing a robust foundation for the entire system. Requirements. Hardware requirements of the project are processor of 5.5 and above, RAM of 8 GB and above, ROM of 25 GB and above. Software requirements of the project are Node.js, Python 3.7.0 version, and Visual Studio Community version. Methodology. To implement this project, we have designed the following modules. The first module is Upload Wisconsin Dataset. In this module, a dataset, possibly the Wisconsin breast cancer dataset, is uploaded. This dataset likely contains information on breast cancer cases, and it serves as the foundation for the machine learning task in the project. Pre-processed dataset. Data pre-processing is a critical step in any machine learning project. This module involves cleaning, normalizing, and organizing the dataset to ensure that it's suitable for model training. Data pre-processing may also involve handling missing values, feature selection, and data splitting. Apply differential privacy. Differential privacy is a technique used to protect sensitive data while allowing meaningful analysis to be performed on it. This module incorporates differential privacy mechanism to the dataset or model to ensure that individual data points remain private and do not leak sensitive information. Build differentially private logistic regression. Logistic regression is a common machine learning algorithm for binary classification. In this module, a logistic regression model is constructed while maintaining differential privacy. This means that the model's training process and predictions incorporate privacy-preserving techniques to prevent any single data point from being identifiable. Extension Private Random Forest. Random Forest is an ensemble learning method. Extending it with privacy features ensures that it can be used in a privacy-preserving manner. This might involve creating a random forest model with differential privacy mechanisms or modifying the ensemble method to enhance privacy. Propose an extension DP error return attack. This module involves proposing and implementing strategies to calculate and reduce the error rate in differentially private models. It also examines potential attacks on privacy-preserving machine learning models and devises techniques to mitigate these attacks. Execute prediction on blockchain node. In this phase, the models trained with privacy considerations are deployed onto a blockchain network. Blockchain ensures secure storage and management of these models and facilitates decentralized and tamper-proof prediction processes. The models can be accessed and used by various participants in the blockchain network. Blockchain integration. Machine learning models are stored on the blockchain, providing redundancy and eliminating single points of failure. Each node in the network maintains a copy, ensuring resilience and continuous access to those critical models. All machine learning activities, including training, prediction requests, and results, are recorded as immutable blocks on the blockchain. This ledger ensures transaction integrity, transparency, and creates a verifiable history of machine learning tasks. The blockchain verifies the accuracy of machine learning predictions, preventing unauthorized changes to models and data. Hash functions play a pivotal role in creating digital fingerprints for predictions, enabling the detection of potential attacks and ensuring the integrity of the verification process. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the dataset folder. To implement this project, we have utilized Wisconsin dataset. Importing this dataset contains the information of diagnosis, radius mean, texture mean, perimeter mean, area mean, smoothness mean, etc. These are main code files. This is run.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Double click on it to start the application. This is the graphical user interface created using Tkinter library in Python. Using this GUI, we will interact with the project. Click on Upload Wisconsin Dataset button to upload the dataset. Select the Wisconsin dataset and open. Here we can see that the dataset is loaded, but the dataset contains both numeric and non-numeric values, but the non-numeric values are not accepted by the machine learning algorithms, so these non-numeric values must be converted to integer. And here, this is the graph. On the x-axis we have the diagnosis name, that is B and M, and on the y-axis we have the value for this diagnosis. Now close this graph. Click on Pre-process Dataset button to pre-process the dataset. Here we can see that the dataset is pre-processed and the non-numeric values are converted to numeric values. Now click on Apply Differential Privacy button to apply the privacy. Here we can see we got a differentially privacy converted dataset, and these are the total records present in dataset, and these are the total features or columns found in dataset. Now click on Build Differentially Private Logistic Regression button to build the private logistic regression. So here we can see we got the DP logistic regression prediction error for 10 participants, and this is the error rate for each participant. Now click on Extension Private Random Forest button. So here we got the extension random forest prediction error for the 10 participants, and here we can see the error rate for each participant. Now click on Propose and Extension DP Error Rate on Attack button. So here we got the graph for Propose and Extension DP Error Rate on Attack. In above graph, x-axis represents epoch or number of trainings for DML, and y-axis represents error rate, and in above graph we can see with increasing participants error rate reduced as DML is getting updated with all participants dataset. Now close this graph. Click on Execute Prediction on Blockchain node button to upload test data, and then blockchain DML will predict cancer from the test records. So here select the test data, open. So here we can see we got the previous hash code, and we can see the block number in which the data is stored, and this is the current hash of DML test record. And here we can see the anonymous test record detail, and we can see that this DML is predicted as malignant. And here we can see another one in which we have the previous hash, block number in which the data is stored, and the current hash, and this is the anonymous DML test record, and this DML is predicted as malignant again. In this way, blockchain will verify previous hash code of current record with last record. The conclusion of the project is, this project brings together the capabilities of blockchain technology and machine learning security mechanism to enhance privacy and data protection. By integrating the two, it creates a robust framework for safeguarding sensitive information and enhancing the security of machine learning applications. The project uses differential privacy, a privacy-preserving algorithm, to add randomization and anonymization to the dataset used for training machine learning models. This step is crucial in preventing data leakage risk, ensuring that individual data points cannot be easily identified or extracted from the dataset. Machine learning models are securely stored in a decentralized manner on the blockchain network. This decentralization promotes redundancy and resilience because each node in the network holds a copy of these models. This approach safeguards against data loss or system failures, ensuring that the models are readily accessible. The project serves as a practical demonstration of the effectiveness of combining blockchain and machine learning in sensitive applications. Examples include credit card fraud prediction, face recognition, and electricity consumption forecasting. By showcasing its potential in these contexts, the project highlights the real-world applicability and benefits of this integrated approach, particularly in areas where privacy and data security are paramount.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.